All right, we're going to be continuing by solving the log equations. All right, our first example is the natural log of x equals -9. Well, calculator's not going to help you with this one, so what do we do to solve this log equation? One of the strategies is if you have a log equation and you can't go straight to the calculator to do the computations, change it to an exponential equation and see what you can do from there. All right, if I'm going to change this equation to an exponential equation, I have to identify that the natural log written this way means I have a base of e. So sometimes for myself, if I see natural log, I'll write in a base of e. Let's change this to an exponential equation. So e raised to the -9 equals x. I think that's the quickest way. I'm going to go right to my calculator and I'm going to type in e raised to the -9 power. And I'll round my answer to 5 decimal places. I would encourage you to put this expression into your calculator and notice what you get. Sometimes we need to talk about this. 1.2340, and it's a 9 and then an 8, so I could round it to 10, but in this case it really doesn't matter. I'm just going to chop off and have 0.9. Okay, what I want you to pay attention to, the important thing is this, e to the -4. Don't write this number down this way. E to the -4 means take this decimal and move it left 4 places. Well, if you're going to move that decimal left 4 places, you're going to be filling in 3 zeros to the left of 1. Right now I'm at 4 decimal places. The requirement is 5 decimal places, so I'm going to keep the 1 and I'm going to bring in the 2 here. And I'm going to disregard the 3409 because I've rounded it to 5 decimal places. So e to the -9 is a very small number, as indicated by e to the -4, remembering that scientific notation, move the decimal 4 to the left, fill in 3 zeros. All right, let's continue solving logarithmic equations. If I could go straight to my calculator, if I knew what x was, I would. I'd do alpha window, but I don't. All right, so on this one, we're going to have a couple of strategies. Not to confuse you, but to give you options, because every problem is different. You never know what strategy you might have to use. Some you can only use one on, some you can use several on. But we want to be prepared for those problems where we can only use one strategy by looking at all the options prior to that. All right, strategy 1. Change it to an exponential. X to the 4th equals 625. Okay, at this point, I know 625 can be rewritten as a power. We saw that earlier. 25 times 25 gives 625, and each of those 25s are 5 squared, so 625 is the power 5 to the 4th. All right. In previous examples and in previous work, when we had the same base, we set the exponents equal. Well, notice what happens here. If I get the same exponent, 4 and 4, if the exponents are the same, then the bases have to be the same. So that in this case, the exponents fall out, and my answer is x equals 5. All right, that's one strategy. Change it to an exponential, try and get the same exponent. Since x is in my base, I want to get the same exponents, and then I can set my bases equal. Okay, alternately, what's another method? Well, this other method, strategy, starts out changing it to an exponential like strategy 1. But how about just bringing in the 4th root? Maybe you saw that over here and you thought, why didn't she do that there? Well, I wanted to make sure you saw the other strategy of getting the same exponents so you could set the bases equal. Yeah, but you might just say, well, bring in for the 4th root. Okay, and another way to think about that is if you bring in the fourth root, what you're doing is you're bringing in a 1/4 exponent. You want to undo the 4 by bringing in its reciprocal because the product here is 1. So come over here and do 625 raised to the 1/4 power. Multiplying here gives me 1. The fourth root of x to the fourth is just x. And then over here, just go simply to your calculator. You get an answer of 5. That's a base of 11. Kind of looks like a pi, but it's an 11. All right, I don't know what x is. I can't go to my calculator and do alpha window, so in a lot of these cases with these log equations, it's beneficial to change the log equations to exponential equations. So 11 to the negative 1 power equals x. I don't know why you do that on your calculator. You're done. Other than the fact that you could change this to 1 over 11. I don't think I'd change it to a decimal. I'd leave my answer exact, just like that. All right, let's solve this natural log equation. I mentioned earlier, if I see a natural log, I don't know if I'm going to go with it, but I'm always going to write in a base of e. In that case, I think I will get rid of the natural log, changing this to the exponential form. E to the 5th equals 2x minus 1. We have to solve for x. Remember, that's just a number. E is just a number, it's not a variable. Let's save our calculator work to the end so that we don't lose any value in our answer. So I want to isolate x. So I'm going to add 1 over here. So e to the 5th plus 1 equals 2x. I'm going to divide both sides by 2 next to get x by itself. I'm going to trade sides. X equals e to the 5th plus 1 divided by 2. That's your final answer. That's exact. If you want to change your answer to a decimal, you'd have to just go to your calculator, set up your fraction bar, dump everything in, round to 5 decimal places. And the result is $74.70658. Okay. Adding another layer here, notice that in this log equation we have 2 log terms. There are 2 strategies for this too. If this equation is equal to 0, I'm going to put 1 log equation on each side of the equation. So I'm going to add over to the other side natural log of 5. Okay, well, what can I do with this? What are some things that are allowed algebraically? If on both sides of the equal sign you have 1 log term, you can drop those out. The natural log of x equals the natural log of 5. Next line down, drop the logs, x equals 5. Now that only works if you have 1 log term on each side of the equation. 1 log, not multiple logs, just 1 on each side. That'd be the easiest way. Another strategy that we're going to use is, and it works well when this side isn't equal to 0, you could use the log properties from the previous videos. When I see a minus with the same log expression, I think the quotient property, I'm going to collapse this into 1 log expression, building a quotient, a fraction, put the x, which comes first on top, and the 5 on the bottom. All right, if I collapse this to one log expression, then think about the base here being e. Now you can change it to exponential form. E to the 0, or whatever number is going to be over here, is equal to x over 5. We know e to the 0 is 1, so go ahead and take care of that. Multiply both sides by 5 as the final step to solve for x. So these 5s will cancel, so x equals 5. All right, a couple more log equations, and then we're going to do one more objective, and we'll be finished. Okay. Oh, actually, we are done with the log, solving the log equations. So those were some examples of some of the homework work that you guys will have. All right, last objective. We're going to simplify the expression. All right, so, a big hurdle for students in math is going to be to read the directions and understand what they're asking for the student to do. I want to point out that in the last two objectives, we've been solving equations. Equations. That word was written down in the directions, and so we have to really pay attention to what the directions are. Simplify the expression. Notice I don't have an equation. There's no equal sign. So I probably won't be changing forms, like from exponential to log or vice versa, because to change from one form to the other, you need an equation to work with. This is not an equation. It's just an expression. Likely you guys know that, but I think it's important to point out the directions and what they tell you in the directions without telling you. All right, you probably already found the answer to this because we've done some previous work. We're just returning to the same previous work. Okay, natural log of e, they undo each other. What drops out is the answer is 7x plus 5. We won't have a numeric answer. When we simplify this expression, we're just going to have another expression as our answer. All right, number 2. I'm still here. To simplify this expression, we just identified that the natural exponential followed immediately by the natural log. Inverse functions undo each other. The answer is x squared minus 3. I'm not solving equations, I'm simplifying expressions based on properties. Number 3, bring down the negative 1 plus natural log of e disappears. 2x drops out. I can't do anything further with that to collect, simplify, etc. So I'm done. Simplifying number 4, bring the 5 down, minus. Those functions undo each other. I'm left with, parentheses are important, minus x squared plus 1. You're not done. Distribute the negative. You're not finished. Collect the constants. So I'm going to end up with 4 minus x squared. This is part of the work that we need to do in section 4. There's a lot going on, but we'll just kind of break it up into a couple of parts. And we'll look at the second part a little bit later.